GMAT 41 is still on the quest to ensure that once students see complex structures like what we refer to as substituent on substituent, they can be able to handle it swiftly without any stress. Is that okay? You would recall that previously we looked at a case where you could have the parent chain, and then the parent chain has an attachment to it, but then this attachment still bears another attachment, and we refer to them as substituent on substituent. To bring the point even much more clearer to us, we illustrated it using a father, which I'm going to call Mr. A. Now I'm giving birth to a son, which I'm going to call Mr. B, and then the son giving birth to another child, which I'm going to call Mr. C. We stated that there is a link between this. Now, this Mr. B is a substituent on this father, Mr. A. And then Mr. C is a substituent on Mr. B. Now, Mr. C is indirectly linked to Mr. A, but through who? Through Mr. B. So you now have substituent on substituent. It was stated that to handle such structure, you would have to, again, number these substituent on substituent, starting from the carbon directly linked to the parent chain, which in this case happens to be what? Mr. B. You start numbering from Mr. B again, because Mr. B is directly linked to what? To this parent Mr. A. Alright, now, having reminded us of what we've treated in our previous class, we now want to move on into classification of alkyls as substituent. Now, I'd like to say this. Once you are able to understand this concept of classification of alkyls, then you are 90 to 99% prepared to handle any complex structure in aliphatic hydrocarbons. Yes. Convince yourself in that, alright? On the board we have classification of alkyls. The first one is primary alkyl, which I refer to as normal alkyl. It takes the general form RCH2, then this bond line is the line linked to the parent chain. So this is the alkyl. It's a primary alkyl because, like we defined previously, a primary alkyl is one in which the carbon of the functional group, which in this case happens to be the carbon directly linked to the parent chain. Are you getting me? That carbon bears only one alkyl. That carbon is attached to only what? One alkyl. Hence, this is a primary alkyl. And I want to state that we didn't have problems here, because attachment of this form are things we may have met even in our O-level organic chemistry. For example, if you hear something like, 2-methyl butane, is that okay? 2-methyl butane. You could hear things like 3-ethyl, 5-methyl, no name. Straight ahead like that, no stress. Now let us move on straight to classification number 2. Very important. This is where the deal begins. Is that okay? In classification number 2, we will talk about isomeric alkyls. These alkyls could either be primary isomeric alkyls, which I abbreviated ISO. Is that okay? Or it could be secondary isoalkyls. How do we identify primary isomeric alkyl? It's simple. Look at it. Remember, primary compounds, the carbon of the functional group or the carbon directly linked to the parent has only one carbon attached to it. That is, only one alkyl attached to it. You can see that there is a carbon directly attached to the parent. Then linked to it is just this carbon. This carbon is directly linked to this. These ones, which are other alkyls, I say they are not directly linked to this carbon. And you can see that this carbon of the functional group or carbon that is directly attached to the parent has how many hydrogens to it? 2. You would recall that I stated that the definition of primary, secondary, or tertiary compound can be seen in terms of number of alkyls attached to the carbon of the functional group or the number of hydrogen atoms attached. If you bear either 2 hydrogens or 3 hydrogens, then it's a primary compound. So this is a primary isoalkyl. Example of such is what we have here. Now let us analyze this compound and see. You notice how many carbons do we have all together here? 4. So it looks like butyl. But this is not butyl directly because it's not a straight carbon chain like, it's not something like CH. If it were to be CH3, CH2, CH2, and then CH2 directly like this, we could say that it is butyl. But this is not that straight. You can see that, right? There is an arrangement of the carbon atom. And you know, the concept of isomerism is all about rearranging the carbon atoms in a given structure to get another structure which is molecularly equal to the original. Does that make sense, right? So this is an isomeric butyl. Because what really happened, if you notice, let me just show something here. This carbon to which this CH3 is attached, let me identify it to be this carbon. Now what happened is as if one hydrogen was transferred. One hydrogen was transferred to this, making this CH3, and then this CH3 was now picked to attach to this. You know, if one hydrogen is transferred to this, this becomes CH3, this becomes what? CH. And then this can be found as an attachment here. That is what we have here. So it's an isomeric what? Butyl. Which is what is pronounced isobutyl in the common name, or otherwise what we call old name. You know, IUPAC nomenclature is actually a system of naming in such a way that once a structure is written, the name is given to you, or you hear the name, you can be able to draw out the structure. Before the advent of IUPAC, is that okay? International Union of Pure and Applied Chemistry system of naming compounds. Before then, we have what we call the common or the old name. So the old name to this is isobutyl, isomeric butyl. In the IUPAC nomenclature level of naming, this is actually 2-methylpropyl. How? This is the carbon directly linked to the parent. So you have 1, 2, 3. On the second carbon atom, you have this methyl. So it becomes 2-methyl. Then take note that these 3 carbon atoms here is actually an attachment attached to the parent. So it becomes propyl. Therefore, we are saying that isobutyl is the same as what? 2-methylpropyl. Does that make sense? Either of them can be used when given the nomenclature of a compound to which this is attached. Let us now move on to secondary isoalkyl. This is the general form it takes. Secondary, you can see the carbon that is directly linked to the parent. This bond line is linked to the parent's chain. This carbon is attached to 2 alkyl groups, or 2 carbons directly linked to it. That makes it a secondary compound. And of course, it is a secondary isomeric alkyl. An example is this compound. Look at it. This is an alkyl. How many carbons do we have altogether? 3. So this is actually isomeric propyl. Isomeric propyl, which can still be named as 1-methyl-ethyl. If you count 1, 2, this becomes an attachment. So it can be 1-methyl-ethyl. So once you see this as an attachment in a compound, you can choose to name it as isopropyl or 1-methyl-ethyl. Please take note, if you name it as propyl directly, it's wrong. It's wrong. Please. Propyl directly is this. Why can I write that? And have a marked space here. Propyl directly is CH3, then CH2, CH2. That's propyl directly. Is that okay? There is an arrangement here, just like you see this. I can move this CH2 to this carbon atom, remove one hydrogen and attach to this CH2, making it CH3, which will be attached to this. It becomes an arrangement. Is that okay? Now, when you see an isoalkyl as an attachment, please take note of this. The iso follows the alphabetization rule. What do I mean by that? If you want to use the common name, you have to respect the alphabetization rule. Iso starts with I. So let's assume that in that compound you have these attachments, or this one which is isoalkyls, alright? And then in the compound you have them. In that compound you also have something like methyl or propyl, the normal alkyl. Are you getting me? Please, you must respect the alphabetical ordering, knowing that I comes before N or P. Which means that this compound with this attachment will be named first. Is that okay? Before you consider the other one. The point is, it follows alphabetical ordering in giving the name. Secondary alkyl is the next one to look at, abbreviated sec alkyl. When you are working with this sec alkyl, look at the general form. Look at the general form. It's a secondary compound similar to this. Is that okay? Similar to this. The only difference is that for this chain, it's a straight chain. But then, it is not a normal alkyl. Because if it is a normal alkyl, let me show you something. Then this would not end at CH3. It's either this ends with CH3, this will be CH2. One hydrogen from here will be transferred to this CH to make it CH2, CH2, CH2. You can now say this is a normal butyl. Is that okay? So that's just the difference between secondary alkyl and then secondary isoalkyl. This form of attachment, once you meet them, you pronounce sec alkyl if you want to use their common name or old name. And of course, looking at it, it's still the same as 1-methyl propyl. Because this carbon is directly linked to the parent. Carbon number 1 now, if you are numbering the sides chain. Are you following? Or if you go this way, 1, 2, 3 will be longest, then 1, 2. This becomes an attachment. The 3 is the longest. So you can answer on the first carbon atom, you have this methyl attachment on this propyl, which is 1-methyl propyl. The same as what? Sec-butyl. In writing, normally, this sec-butyl, if you're using the old name, the common name, the sec-butyl is italicized. Is what? Italicized. Although that now has to do with, in the case of typing and other things, alright? If you're writing with pen, I wonder how you can italize. I try to, but it's not funny. Okay, now let us move on to the last classification, which is tertiary alkyl. We know tertiary compounds already. The carbon of the functional group, or the carbon directly linked to the parent in the case of alkyl, will be attached to 3 other carbon atoms directly, or 3 alkyls. And you can see that this is a carbon directly linked to the parent chain, labeled as carbon number 1. On this carbon, you can see 3 alkyls linked, 3 direct carbons linked to it. Is that okay? Now, an example of such compound, you see this. How many carbons do we have here in this alkyl? 4 carbons. 4 carbons. So it's actually a tertiary butyl, which is abbreviated as Tert butyl. Tert butyl. But we can use the IUPAC system of naming. If we do that, you come to this. This is a carbon directly linked to the parent. So carbon number 1. On that carbon number 1, you have a methyl, you have another methyl. How many? 2. So you can name it as 1,1-dimethyl. And you see the longest chain, if you consider in this way, or in this way, or in this way, is 2, 2. Is that not so? So it becomes 1,1-dimethyl ethyl as the attachment name. If you're dealing with secondary alkyl or tertiary alkyl, that is sec alkyl or tert alkyl, the sec or the tert is dropped in alphabetization. You don't consider it. Just like you have di, tri, tetra. You don't consider them in alphabetization order. Which means, for example, if I have tert butyl in a compound and I have methyl in that compound, I will drop this tert and then but will be considered first because but starts with B, while methyl starts with what? N. Take note with iso, you consider the prefix iso, is that also? But for sec and tert, you don't consider the sec, you don't consider the what? Tert. That is if you want to use the common name. If you want to use the IUPAC system of naming, it follows our normal rule, which we already stated previously in terms of alphabetization. And watch this video again and again. You can subscribe to our channels. Please, we appeal to you as we bring to you wonderful concepts of learning. In the next video, we are going to look at these structures and it will be very sweet to deal with.